Okay guys, welcome again. So last time we did the calculations of an empirical formulas, and we also did like the explanation and the definition. So today we are going to solve the problems related to empirical formula. So here is the first question, that what is the empirical formula for a compound whose percentage composition 21.6% sodium, 33.3% chlorine and 45.1% oxygen. So we have three atoms: sodium, chlorine and oxygen. So first of all, we need to find the moles of each atom by using the percentage composition. So here let's suppose we are going to write sodium, here is chlorine and here is oxygen. So let's suppose here is 21.6%, that is like we can consider it as 21.6% grams of sodium. Now here the next one, chlorine, that is 33.3%, so it means here it would be 33.3 grams. And the oxygen, that is 45.1%, so here is 45.1 grams. Like that is the mass. Okay, now what will be the atomic mass here? The atomic mass is, that will be, here is, or the molar mass of sodium, that is like 22.99 or 23, and the molar mass of chlorine, that is 35.45, while the molar mass of oxygen, that is 16 or 15.99. So now first of all we need to find the number of moles of each atom. So here the sodium would be 21.6 divided by 22.99 is equal to N. Here is 33.3 divided by 35.5 is equal to N, and here is 45.1 divided by 16.00 divided by N, because we know that the moles N is equal to mass divided by molar mass. That is the formula for finding moles. Okay, now here when we divide it, so here the answer will be 21.6 divided by 22.99. So here the answer is 0.94, and the next one, that is 33.3 divided by 35.45 here. So divided by 35.45. So again here we got 0.94, and the next one, that is 45.1 divided by 16.00. So we got 2.82. Now as we know that the empirical formula is the simplest whole number ratio, but there will be no whole numbers. So we need to divide by the simplest number, so that is, or the smallest number. So here we have dividing by 0.94 to obtain the lowest ratio, dividing each by 0.94. So when we divide it, so there the answer will be 1. Here is the answer is 1, and here the answer is 2.82 divided by 0.94, that equal to 3. So it means we got the ratio that is 1:1:3. It means that here will be in the empirical formula that contain 1 sodium, 1 chlorine and 3 oxygen. Here is 3 oxygen. So that is the way in which we can find the empirical formula. So that is our answer. Okay guys, so our next question is, the percentage composition of two antibiotics are given below. Find the empirical formula of each. So first of all, the first one, that is chloromycetin, that contain 40.87% carbon, 3.72% hydrogen and 8.67% nitrogen and 24.77% oxygen and 21.98% chlorine. So first of all, we are going to solve part A. So here we have oxygen, like first we need to write here, that is carbon, hydrogen, nitrogen, oxygen, and the fifth one that is chlorine, Cl. Okay, so first, that is 40.87% carbon. So we can consider that 40.87 grams, okay, of carbon. Now the next one, 3.72 hydrogen, 8.67%, that is nitrogen, 24.77% oxygen and 21.98% chlorine. So first of all, here we need to find the number of mole of each atom. For that we will use the atomic masses, and then we can use the formula, that is mole is equal to mass divided by molar mass. So here we have to divide by 12. Here is like 1.008. Here is normally, like you can say, that is 14. Here the oxygen, that is 16. Like you can take the exact molar masses, and here that is 35.45. So first of all, when we divide it, so we got 40.87 divided by 12. So here we got 3.406, and the next one, 3.72 divided by 1.008. So here we got again 3.690, and the next 8.7 divided by 14. So we got 0.621, and for the oxygen, that is 24.77 divided by 16. So here we got 1.548, and the last one, that is 21.98 divided by 35.45. So we got 0.621. So now here these are not the simplest whole number ratio, so we have to divide by the smallest number, like by each number. So here the smallest number is 0.621. So it means that is the smallest number, or you can take this one. So now we have to divide each number by 0.621 like that. And here we got 1 when we divide it, and then the next one 1.548 divided by 0.621. So here we got 2.5, while the next one again here in this case nitrogen, that will be 1, and for the hydrogen that will be 3.690 divided by 0.621. So here we got 6, and the first one for the carbon, there will be 3.406 divided by 0.621. So here we got 5.5. So as we see that there are the two numbers that are not in a whole numbers. Like here is one is 5.5 and here is 2.5. So you have to multiply all numbers by 2 to get the whole numbers. Like here, when we multiplied the first, then it will be 11, because 5 times 5, 5.5 times 2 equal to 11. The next number, that would be 6 times 2 equal to 12. The next number, nitrogen, that is 1. 1 times 2 equal to 2. While for the here is the nitrogen, and then here is oxygen. So oxygen is 2.5. 2.5 times 2, that equal to 5. And for the chlorine, that will be 2 times 1 equal to 2. So it means here the empirical formula will be C11 hydrogen, that will be 12, nitrogen will be 2, and oxygen will be 5, while chlorine will be 2. So that is the answer of this problem. Okay guys, so here the students, the next problem is sulfonylamide that have the percentages of different atoms like carbon, hydrogen, nitrogen and oxygen and sulfur that are present in the sulfonylamide. So we have to find the empirical formula of sulfonylamide. So here I am going to solve that one. So you can see now we have, again we are going to make the divisions. For example, here the carbon, hydrogen and like the sulfur, nitrogen, like we have 1 2 3 4 5. So 1 2 3 4 5. Okay, now we are going to start. So here is the carbon, that is 41.86, while the hydrogen, that is 4.65, while the nitrogen, that is 16.28, oxygen, that is 18.60, while the sulfur, that is 18.60 again. So now we are going to divide by their like the atomic mass or the molar masses. So here is 32, here is 16, the nitrogen is 14, hydrogen is 1 or 1.008, and here the carbon is 12. So when we divide it, so the answer will be like 41.86 divided by 12. So we got 3.5, the mole equal to 3.5. Here is 4.65 divided by 1.008. So we got 4.6. The next one, that is 16.28 divided by 14. So we got 1.16. The next one for the oxygen, that is 18.60 divided by 16. So we got again 1.16. And the next one, that is sulfur, 18.60 divided by 32. So we got 0.58. Okay, now 0.58 is the smallest number. So divide each term by 0.58. So here we got 1. When we divided 0.58, so here we got 1.16 divided by 0.58. So we got here 2, and then 0.58, again that is the same number. So here again we got 2, and in this case 4.6 divided by 0.58. So now 4.6 divided by 58, so we got 8, while in this case 3.5 divided by 0.58, so 3.5 divided by 0.58, so we got 6. So it means the empirical formula would be, here I am going to show you with different color, that is C6H8, then N2O2S, N2O2S. Alright, okay, now the next example, that is little bit different because here are the two oxides of the that are given the percentages in the two oxides, like the oxygen percentage. Now the question is, phosphorus combined with oxygen to form two oxides. Find the empirical formula for each oxide of phosphorus if the percentage composition for each is 43.6% oxygen, and in the next oxide that contain 56.6% oxygen. So now here we are going to solve again, like for example here is A oxide, here is B oxide. The A oxide contain 43.6 like grams oxygen or the percent oxygen, and the like oxide B contain 56.6% oxygen. Okay, now if the oxygen is equal to 43.6, so we have to, like the percentages, it means that is we have to subtract 43.6 from 100. So here is 43.6, so it means here it would be 56.4% phosphorus, while in the next one 100 minus 56.6, so we got 43.4% phosphorus. So now again we need to solve the oxygen and phosphorus moles, we need to find. Okay, so here oxygen and phosphorus. So as the oxygen is 43.6 and phosphorus is 56.4, let's suppose these are the grams. So now we need to find the moles of each atom. So in the second one, again here the oxygen is, and phosphorus. The oxygen is 56.6 while the phosphorus is 43.4. So as we know that the atomic mass of, like the oxygen is 16, so we have to divide by 16 here, and the atomic mass of phosphorus is approximately 31, and again we have to divide here by 16, and here is 31. Okay, so first of all, when we divide 43.6 divided by 16, so we got 2.7, and in the next case 56.4 divided by 31, so we got 1.8, while here the oxygen is 56.6 divided by 16, we got 3.5, and in case of phosphorus, so that is 43.4 divided by 31, so we got 1.4. Okay, now like if we see that 2.7 and 1.8, these are not the whole numbers, so we have to divide by 1.8. So 2.7 divided by 1.8, so here we got 1.5, and here is 1.8, we got 1. While in this next case, when we divide 3.5 divided by 1.4, in this case when we divide by 1.4, because here 1.4 is the smallest number, so here the answer will be 2.5, while here is 1.4 divided, so it means that will be 1. Okay, now again you can see here is 1.5, here is 2.5, so it means that both oxides are not in the whole number, so we need to multiply by 2. Alright. Okay, now the first oxide that contain like 1.5 times 2, that equal to 3 ratio, and 2 times 1, that equal to 2. So it means that here the oxide that contain P2O3, so it means that is the first oxide. While in the next case, when we multiplied 2.5 times 2, that will equal to 5 ratio, and 2 times 1 equal to 2. So here the oxide will be, the empirical formula of that oxide is P2O5. Alright students, so that is the way in which we can find and we can calculate the empirical formula. So thanks for watching, and if you like our video, so then do subscribe and share. Thank you. Goodbye.